Recording progress.
Hello, everyone. In this video, I will go over how to run the basic actor-partner interdependence model within the Mplus software. If you're not familiar with Mplus, I'll do a brief introduction. And so there's going to be several core elements that you are going to have in your Mplus syntax, and they're going to be in blue. Including title, data, variable, define, analysis. Model plot is obviously optional, and output as well. And so in your title section, I just have baseline APIM, and this is where I actually take a lot of notes because the Mplus software essentially it completely ignores whatever's in the title. So if I have 3 or 4 different data files, I will say data 1 equals no outliers, data 2 equals male. I'm analyzing males and females separately or whatever it is, but that's where I take a lot of notes so I know kind of what my files mean. And then in the next, you'll see the data command, and then you'll start the syntax with file is, and then you will specify your .txt file, or in this case, .dat file. And so if your data file and in your input syntax are in the exact same folder, then you don't need to specify or hard code the pathway. And I'll show you what that looks like. So here's my folder. And so the APIM is the input file that I'm using in Mplus. And if you scroll all the way down, my data file is couples.dat. And so they're in the exact same folder. And so I don't need to do anything special. In my data file in this couples.dat, I have 8 variables: dyadic coping for males, relationship mindfulness for males, depression for males, and relationship quality for males. And I have these exact same variables for females. In my use variables command, I'm only using 4 of the 8 variables. I'm looking at dyadic coping for males and females, as well as relationship quality for males and females. If you're using all 8 variables, then you can comment this out by using an exclamation point, and Mplus will ignore anything that's green. And this is telling the Mplus software that you are running all of your variables that are in your data file. But we're only going to be using 2 of them in running the basic actor-partner interdependence model. So your define command, we actually won't be using here, but this is where you conduct transformations or sum scores, or you change your variables in any way, shape, and form. For example, if you have item level data in your .dat file, and up here, you can create sum scores in here. All right, so I'm just actually going to remove that as to create confusion. And then in the analysis command, this is where we specify what type of model we're running, our estimator, things of that nature. And so I'll be using robust maximum likelihood, or MLR, which is maximum likelihood estimation with a Yuan and Bentler correction to the chi-square to account for non-normality, because we will be looking at relationship quality as our dependent variable in this actor-partner interdependence model, and those data are almost never normally distributed, or specifically the residuals are never normally distributed. So we need to enact this correction to obtain correct standard errors and correct chi-square statistics. In the model, which we will build now, I will walk you through how to enter in the syntax for the actor-partner interdependence model, and we'll get down to the plot and the output after we finish the syntax. So our independent variable is going to be dyadic coping for males and females, and our dependent variable is going to be relationship quality for males and females. So there's a couple ways you can code the syntax. So you can do this in very few lines of code. So you can do CSIM for couple satisfaction inventory for males, couple satisfaction inventory for females. This is your regression statement. So this is our dependent variable being regressed on and then our independent variables. And I'm gonna copy and paste her. So I'll throw that in there. So essentially what this is doing is I'm telling Mplus regress CSI male on both dyadic coping for male and dyadic coping for female, which is a part of the actor-partner interdependence model. All right. And then I'm doing the same thing with CSI female. I'm having CSI female being predicted by dyadic coping for male and dyadic coping for females. All right. And so also part of the actor-partner interdependence model is our independent variables and our dependent variables are correlated with one another, much like you would see in a cross-lag panel model. And so here, what we can do is, I'll just copy down this. And so we have couple satisfaction for males and female, and we'll use a with statement. Right? And so in Mplus, on means regression, and with means a covariance or a correlation. Right? And you will notice at the end of every line, for those of you who are not familiar with Mplus, there is a semicolon, and that tells Mplus that the command is stopped. It tells Mplus to move on to the next command. Otherwise, you can get lots of nonsense errors, and Mplus will occasionally yell at you. And so we'll do the exact same thing with dyadic coping, that we theoretically believe that the extent to which males cope with their partner is correlated, or is not independent of the way females correlate or cope with their partner, much like we would expect that males' reports of relationship quality or relationship satisfaction would have a non-zero correlation with their partners or the females' reports of relationship quality and relationship satisfaction. Right. So this is the shorthand way of coding the actor-partner interdependence model. All right. And so I will show you another trick. If you do exclamation point and then an asterisk, this is a blocking feature of Mplus. So Mplus will not read in anything that is highlighted here that is between this exclamation point and asterisk. All right. And so down here, I'll show you another way to code in the actor-partner interdependence model. And so first will be CSI-M on the dyadic coping, and Mplus is not case sensitive. And so we'll do that. And then we'll do CSI female on, oops, this was typo, on dyadic coping for males, right? So this is the actor effect, that within person effect that you have probably read about in the APIM. And this is the partner effect. So this is the extent to which males' reports of dyadic coping predict female relationship satisfaction. And there's not really a organizational strategy. I'm organizing it as my dependent variable is consistent. And so but you can easily move things around and order the code and syntax in pretty much whatever way you want. And so we need to mirror this again. So the CSI male, this is going to be on, this is dyadic coping, but for the female this time. So this is going to be a partner effect. All right. And then you have CSI CSI female on dyadic coping for the male. For the female. All right, and so these are the four regression coefficients, and these are going to stay exactly the same. So these two lines of code, or these two ways of coding things, are exactly equivalent. You'll get the exact same answers. I tend to do it the long way, because if you put in model constraints, which you generally do in dyadic analysis, if you've heard of the ISAT model, you want to constrain the actor and the partner effects to be the same. Mplus will yell at you if you try to do that all in one line of code. So I end up doing it the long way. And I will go over the ISAT model in a separate video if you are interested in how to code that in Mplus. And so I will actually just delete this, and then we can go down to the plot. So type equals plot 3. This just gives you the ability to create histograms and scatter plots for your residuals, for your correlations, for your covariances, for your outliers. And this is not necessary in Mplus or in any analysis. This is just personal preference. That when I'm running analyses, I want to know if there are influential observations, and so I can figure out what to do with them. The final line of within this syntax is the output. And so SAMstat is just your descriptive statistics. So it'll be your means, your variances, skewness, kurtosis, things of that nature. Residual is tells Mplus to give you your residual matrix, which is your observed versus model implied covariance matrix, which essentially looks at local model data fit. It'll tell you whether some parameters are overestimated with a negative value or underestimated with a if they're overestimated, then it's a positive value. And if it's a negative value, that means the parameter is underestimated. Right? Then you have STDYX. That means I'm standardizing both the X and the Y. You could also do STDY, that's standardizing only your dependent variable. If you have a binary predictor, that can come in handy, or you could do STDX. All right. But I just standardize both. And so Mplus will give you unstandardized output by default. And I'm just telling Mplus, I want to see standardized as well. I'm giving mod indices as a request. I can already tell you right now that our model is saturated. It's not going to have any degrees of freedom. So this input is not going to yield anything of interest. And then I'm requesting 90, 95, 99% confidence intervals. And so we can go ahead and save it, and then we can go ahead and run it in Mplus. And we can scroll down. And so this is just a summary of analytics. You'll often want to look here to ensure that if you're working with missing data, for example, that all of your cases some of your cases didn't get excluded. You want to know that you have the right number of IVs and DVs, right number of groups, things of that nature. All right. Here are your sample statistics for your means and your covariances and your correlations. Mplus does not give you statistical significance up here. You have to code that, excuse me, into your model under your model command up here if you want those actual correlations and their significance values. So here is our model data fit. Again, we have no degrees of freedom, which essentially means we are estimating all of the parameters that we possibly can within this model. Okay, if you remove a pathway, for example, then you'll get a degree of freedom. But our model is saturated, so this will always be 0, these will always be 1, and this will always be 0 as well. All right, and so model data fit isn't of consequence here, so I'm going to move on, and here is our unstandardized results. All right, so these are in the raw metric. And so what we can see is that we have some significant findings right here. And this is for the CSI, so relationship quality from males is being significantly predicted by dyadic coping for males. So the higher levels of dyadic coping that males report, also males tend to report higher levels of relationship quality, and that's our parameter estimate and standard error and our test statistic and p-value. Likewise, we have a partner effect. So that's where one dyad member influences another dyad member. And the partner effect is 0.241. So this means for a 1 unit increase in the female's level of dyadic coping, male's relationship quality increases by 0.241 raw units, which again isn't all that interpretable, is not all that meaningful, which is why we will eventually head down to those standardized results. Likewise here, we have women's reports of relationship quality, and we find that that the males' reports of dyadic coping are not related to females' reports of relationship quality, accounting for female reports of dyadic coping. So beyond females' own reports of dyadic coping, male report of dyadic coping has no influence on how happy or satisfied women are in their relationship. All right. So these two will be your partner effects right here. And then the top and the bottom will be your actor effects, the within person effects. And here is our covariances between relationship quality and dyadic coping. Again, I don't know what 2.85 means, which is why we use the standardized metric, which will be your correlation. Where I do like unstandardized a little bit better is that it gives you means. All right. I like having these means because they're a little bit more interpretable because they're directly related to the scale that you use, and so I can kind of put that in context a little bit. Whereas in the standardized results, you don't get that. And these are your adjusted means of your dependent variable right here. And then we have our variances, and then we have our residuals, which again, I don't really know how to make sense of 9.419. Is that big? Is that small? I don't really know. So that's where moving down to our standardized effects can be helpful. For our standardized effects, we see that a 1 unit increase in males' report of dyadic coping, which is in standard deviation units, yields a 0.47 unit standard deviation unit increase in males' relationship satisfaction, whereas females, a 1 standard deviation increase in their females' reports of dyadic coping yields a 0.228 standard deviation increase in male relationship satisfaction or relationship quality, and that is significant. Again, these p-values will slightly differ from those above, but most of the time they are not going to lead to substantive conclusions that are any different. And likewise down here, again, the same substantive findings as above. Male dyadic coping is not associated with females' reports of relationship quality. So there is no partner effect from males to females. But again, we see that female reports of dyadic coping increase 0.39 standard deviation units with every unit increase in dyadic coping. All right, and here are correlations. So 0.35, rounding up slightly, that tells us the level of residual correlation between relationship quality between males and females. And then we also have our covariance between male and female reports of dyadic coping, which is 0.54. And then further down, we have R squared, which is the amount of accounted for variance. And as you can see, there's a lot of variation here. And so we accounted for nearly 40%, 38.9% of the variation or individual differences in couple satisfaction for males is accounted for by the model, which is actually quite high. For females, it's only 17%. And so that in and of itself is something that is highly, highly, highly interesting, that dyadic coping among dyads accounts for way more variation in how happy males are compared to how happy females are. Down here, you have confidence intervals. You have, again, the lower 0.5%. Then you have your lower 2.5%, the lower 5%. All right. And then you have those confidence intervals that are standardized as well. Again, these will not give you or should not give you any substantive differences in conclusions, because rather than dividing by your standard error to obtain your test statistic, you are just multiplying by 2 times your standard error to obtain these confidence intervals, or 2 times the standard error to get the 95% confidence. All right. And then we have residual output, which again, in our model, this is generally where I go to see if there's any model data misfit. But as you can see, these values are not calculated because they are too small. And so generally that means we don't have to worry about them. If you see a 999 here, And if you see a 0 here, that means the expected score matches the observed score of what the model would have expected. And then obviously I said earlier, modification indices would not yield anything. That's because we have no degrees of freedom. All right, so that is a brief rundown of the actor-partner interdependence model within an Mplus framework. Hopefully this video was helpful for you in just dipping your toe into dyadic data analysis within an Mplus framework.